saya ni balik. Alright. Okay, so dalam triple integral, so we have same thing, type 1, type 2 or type 3. It depends on where you are looking at. Okay, kalau saya tengok dekat XY plane, saya tengok daripada pandangan yang pertama ni. So this is on XY plane, or I can also make it into ZY plane daripada this kacamata yang kedua. So this is type 2. And this is type 1. And the rest is type 3. So kalau saya tengok kat sini, ketiga-tiga type ni dia menunjukkan kepada segitiga. So dalam kes ni saya tak kisahlah saya nak tengok mana-mana pun. Tiga-tiga tu benda yang sama. So saya rasa yang paling mudah adalah type 1 sebab dia melibatkan X dengan Y. Okay, and then the function will be f of X and Y. Fx. Okay, for example, contoh kat sini. Find the volume of the tetrahedron bounded by coordinate plane. Plane should be plane here. And the plane z equals to 4 minus 4x minus 2y. Okay, the key right here is bounded by the coordinate plane. It should be planes. And the plane z equals to 4 minus 4x minus 2y. Okay, so first of all, kita kena tengok dia punya boundaries. Look for boundaries. Okay, so kalau kita lukis balik, if you draw this z-axis, and then y, maybe that way. And then x. Okay. Benda yang paling mudah kita buat adalah kita try lukis. Macam saya banyak kali saya bagi tahu, try lukis sebab kita nak tengok by sketching. Okay, let's see. So this is z, this is x, and this is y. Kalau kita tengok what makes when x and y equals to 0, z intercept is 4. Okay, so z intercept is 4 when x, y equals to 0. And then kalau kita tengok when x and z equals to 0, y akan jadi 2. So maybe I can just write here. X, y equals to 0. So z equals to 4. So the z intercept is 4. And then kalau kita tengok bila y and z, x and z equals to 0. So meaning we want to find the y-intercept. So it will be 4 divided by 2. So this is just this point right here, 2. And then we can see that z and y equals to 0. And therefore x equals to 1. Okay, so the graph looks like this. The surface, not the graph. It's something like this. Okay. So this is the function. Okay, so the function of the surface is what? Is the z-axis, right? So this is like z equals to the function for fx and y. So this is equals to 4 minus 4x minus 2y. Okay. So dalam kes ni paling ringkas kita tengok daripada atas. So look at from above. So the plane yang terbentuk adalah So this is x, not what, this is y, and then this is x. Okay, so the intercept will be 1 and 2. Okay, so the boundaries is enclosed by yx, y equals to 0, x equals to 0, and this equation line. So this is the boundaries for x, y equals to 0, and then this is y equals to 0, the boundaries. And then this is x equals to 0. This is the boundaries on the vertical part. Okay, and then this one, this line right here is the equation line. Okay, so we need to find this equation line. Okay, so kalau tengok kat sini, what's the equation line? So y-intercept is 2, and then the slope is 2x, a negative slope. So this is type 1, right? So type 1 because we can see that if you pick one value right here, x goes from 0 to this function. Pun boleh. Or maybe if I want to change my orientation, I can also pick this point and then goes along y direction. I can also end up on the same line for any point. Okay, so which one is easy? So since that we have the boundaries, type 1, that one I think is easy because we have y equals to 0 and then y equals to 2 minus 2x. Okay, so we can say that an x goes from 0 to 1. So we can write our function. This is the r function fxy and then dA. So in this case, I don't have to use triple integral because I can see that this is just regular surface plane bounded by 3 axes. And then you can see that we can use just double integral like usual. Okay, so the region is what? The region is x goes from 0 to 1. Okay, so this is y limit, so y equals to 0, and then y equals to 2 minus 2x. Fx is what? Fx is the surface z, 4 minus 4x minus 2y dy dx, not 2y, that's 2x. Yes, that's right. Okay. So please be careful with this. So you can see that because the limit is for y, so it should be dy first, and then the outer limit is for dx. So dx is the outer part. Okay, so we can now solve that. So the inner integration. So we need to solve y equals to 0 until y equals to 2 minus 2x, 4 minus 4x minus 2y dy. So this is iterated integral. So kita buat satu-satu, do it one by one. So this is just now x is a constant. So we have 4x minus 4xy, okay, because this is a constant. And this is also a constant. 3x as a constant. And then it should be y, not x. This one should be y. 4y minus 4xy and then minus y squared evaluated from 0 to 2 minus 2x. Okay, so any questions so far? All right, so we don't have any question. I think this is so direct to the point, and then we can see that this is 4 minus 2x. So just plug in y. So this is 4 minus 2 minus 2x, and then 4x times 2 minus 2x minus 2 minus 2x squared. Okay, so we just plug in y. This is y over there, then y squared. There's no question about that. Okay, and then minus 0 because everything is multiplied by y. Y is 0, is minus 0. So if you do the algebraic manipulation, you can get something like 4 minus 8x plus 4x squared. Okay. So this is just the inner integral. And then finally, you can do from 0 to 1, put it your inner integral evaluation, 4 minus 8x plus 4x squared dx. You be careful with the parentheses. In this case, it's a bracket. Be careful with that. Okay, so when you integrate this, it will be 4x minus 4x squared plus 4x cubed over 3. And then evaluate from 0 to 1. Okay. So you can see that everything is just 4 times 1 minus 4 times 1 plus 4 times 1 over 3 minus 0. And the answer will be 4/3. Okay, so this is 4/3. So this is the answer for this one. Okay, how about if I change my point of view? Meaning that I want to change, let's say I'm looking at this direction. So I want to look at that direction. Okay, so you knew that the answer should be the same. Why? Because this is the volume. The volume doesn't change because this is a solid. A solid doesn't change its volume unless you are referring to a gas or fluid, something like that. Other than solid, it will not have the same volume. But this is a solid, then it should have the same value. So meaning that if you look at different angle, and then you will have the same output. Okay. So the problem is not your point of view. The problem might be which point of view is easier to evaluate. Okay. In this case, you can see that it's not a problem in which direction, because at every direction the output, the projected area will be always a triangle. The only problem is what kind of equation of that triangle that you are going to solve. Okay, now if we change our point of view, let's say we are looking at this one, zy plane, yz plane. So we are looking at this direction. I don't want to solve it, but I just want to give you the gist of the problem. And you need to make sure that the output should be the same. So this is z-axis, and then this will be y-axis. Z-intercept at 4, y-intercept at 2. So the triangle form is like this. Okay. And then the should be lebih kurang lah. Okay, tak apalah. Just a sketching problem. Okay, so this is the area that we are interested in. Okay, now what changes? The thing that change is your limit as well as your equation. So this is what? This is z in terms of what y. Okay, and also your surface equation. There's no longer fxy. It should be in terms of f, y, and z. Because we are looking at z or yz plane. Okay, so the first thing, let's try to figure out what's the function in y and z. Okay, the original function we have z equals to 4 minus 4x. Is it minus or plus? Is it minus? Minus 2y. Minus 2y. Okay, now we are looking for x on the left-hand side. So it should be 4x equals to 4 minus 2y minus z. So therefore, we can have x equals to 1 minus 1 half y minus z over 4. So now we have this is equal to our surface function in terms of y and z. So this is one equation that we get. All right. And then how about the line connecting z-axis and y-axis? Okay, so the equation, just use a simple. You don't have to calculate everyone. Just use calculation in your mind. So there should be z-intercept minus the slope, which is 2y. Okay, so that's easy. And then this line is correspond to z equals to 0. And then this line correspond to y equals to 0. Okay, so we can see that you can also use the same thing. Z start from 0 until z equals to this. Okay, so the setup will be, now we have the region R in YZ plane, Fy of z dA. And then this equals to, so we need to define the limit, upper and lower limit for the integral. So Fyz is given 1 minus 1 half y minus z over 4. Okay, so since we are integrating z as inside, so this is start from 0, z equals to 0 to z equals to 4 minus 2y. So therefore, the inner integral will be integrated in with respect to the z. Okay, so the outer integral will be from y from 0 to 2. 0 to 2. So this is dy. Okay, so this is just the setup. You can see that if you do the math, everything will be the same. So this is also the same as for third of unit Q. This is I will left this as your exercise. Okay, let's look at a different topic, new one for today. Okay, any questions so far? No. Tak ada question tak ada soalan So kalau ada soalan, do not hesitate to ask me. Even outside the class, line integral. Okay, so kita akan ke topik yang seterusnya iaitu line integral. This is in 4.5. Okay. What is line integral? This is your. Okay. So let's say line integral. So in xy plane. So in xy plane. Okay. A curve C. C-U-R-V. Curve C can be expressed in terms of parametric equation. Okay, last time I told you what is it about parametric equation. For example, if I have x, and then my function will be, my x will be in terms of Rn theta, and then y might be in terms of Rn theta as well. So this is parametric equation. Now I want to change this notation. This is in polar coordinate. So in general, I can say x is a function of phi of t, and then y as a function psi of t. And t is real number from A to B. It can be an angle, it can be some other space. Okay, so t can also be time. So that's in general. So and then let's say if I have this function phi of t, and then I have t plus t naught. So meaning that you increase one value. So for example, if I have this is t, and then the difference is this is t naught, so increase by t naught. Okay, and then I have phi t plus t naught. Okay, so this is a different function, the same function but different position, perhaps. Okay, so at different position, let's say I say something like this. Phi of t is equals to phi of t plus t naught. So katakan, let's say phi of t, let's say this is phi of t. At increasing time, okay, this is in general, increasing time, this is t. So after t times, and then you came back to your original position. So even though this is t plus t naught, at increasing time, you end up at the same point. So this is called closed curve. So return back to original point. Then this is called closed curve. So yang ini penting. Dan sama juga, same thing. If I have psi when t increased by t naught, this is also equal to the position at t. So in both cases, so this is also a closed curve in both cases. All right. So let's define what is closed curve. Kalau kita tengok dekat, let's say, let's try to sketch. Let's say I have a line from here to here. Let's say this is position A to position B. And then I go from left to right. So this is a curve, but not closed curve. Because I end up at different position. How about this one? A to B. So this is like a loop. So this is not a closed curve. Not a simple. It closes on only at this particular curve, but it is not a simple closed curve. Not a simple closed curve. It closes at only some points. Okay, sama juga. Let's say the same thing. If I have something like this, tak cantik. So if I have something like this, okay, this is also not simple closed curve because you have the inner curve inside. Closed curve but not simple, and closed but not simple. Now a simply closed curve. Okay, yang simple adalah yang ni. Just one. Look. This is closed curve. Simple closed curve. How about the direction? Does it matter? Yes, it does. You go that way or you go this way. Okay, it differs. So it might be resulting into the sign changes from positive or negative parts. Okay, so and then the convention of simple closed curve is this convention. Convention. It should be in counterclockwise. Okay, CCW. This is positive convention. So this one is negative. So if you go counterclockwise, this is the positive convention. Otherwise, it's negative. Okay, an example. Example of simple closed curve. As you can see, this is like just like a regular circle. And then the regular circle of radius, let's say maybe radius r. Okay, so the parametric equation for this one is x equals to r cosine of t, and then y equals to r. Oh, I don't want to use r because maybe you are confusing with the other one. Let's see, r is constant. Okay, I don't want to use r. Okay, maybe I can use a. So a is a constant. A cosine t, and then y equals to a sine of t. And then t goes from 0 to 2 pi. Okay, so this start from 0. This is 0, and then go back to 2 pi. Then a is constant, not a variable, because we are only looking at one particular variable. Okay, so what is line integral? Okay, so we have, there are two kinds. So we have line integral with respect to x. What does it mean? So it means that it is single integral on line C, curve C, f x y dx. Okay, if you have line integral with respect to y, and then you can just change your d into dy. The only thing that changes is this. So this is with respect to x. This is with respect to y. Or maybe we can have both x and y. So if you have both x and y, the line integral will be the integral on curve C fxy dx plus g x y gy. So C can be closed or not closed. And then the notation is this C, and then this is versus this C. Okay. So this means that this is open curve. This means that this is closed curve. Because this is, you have a small circle right here. And then in some cases, you can also have something like this, integrate on C. And then you have the direction of the orientation of curve C. Okay, so this is the positive direction. In most cases, we just leave it as that. In most cases, we don't really use, because the convention is, you need to bear in your mind, remember that counterclockwise is the positive convention. Unless you want to specify the other way, then you can do it. All right, let's see this example. Evaluate line integral from -1 to 0. So this is like a point on xy plane, -1 to 0. Oh, that's not minus, that should be positive. Okay. And then your function fxy is x cubed minus y cubed dy. So this is with respect to y. And then through semicircle, y equals to 1 minus x squared. Okay. So if you draw this, or if you sketch this on xy plane, okay, if you sketch this, simple one. Okay. So the point 1, 0 is right here. The point -1, 0 is right there. And then through semicircle, not through this line, not this line. This is through this line. Okay, through the semicircle, y equals to 1 minus x squared. So this line. Okay, so this is through this line. We highlight that. So this is the line that we are going to do the integral. Okay. And then let's see the orientation. This says that from 1, 0. So it's the starting point is right here. The ending point is this point, end point. So the orientation is from right to left. So this is in counterclockwise, which is um, our convention. So this is okay. Okay. Any questions so far? All right, so that is soalan. So let's see, what's the parametric equation? So this is easy because this is just a circle. So always a circle in terms of cosine and sine. So we have x equals to a cosine of t, and then y equals to a sine of t. Okay, and then what's a? A is the radius. Radius is 1. Okay, and then how about t? The boundaries for t. So t goes from 0 to pi, just pi, not 2 pi. So this is from 0 to pi. Okay, so t from 0 to pi. Okay, now we can plug into our line integral in C, x cubed minus y cubed of dy. So this equals to the parametric curve from 0 to pi, and then x cubed is just cosine cube minus sine cube t dy. What is dy? Dy is sine t, so will be cosine t. Because we are looking for dy. So dy so you can do the integration. I don't want to do it one by one. So the answer, you just plug in your numbers, and then this is 3 pi over 8. So you can show your integration. You can do it one by one, or you can use substitution or by part, and so on. Okay, before we go further, I want to explain what is line integral. What is line integral? So line integral, if you have something like this, some kind of path, let's say from A to B, okay, and then you walk on this path. So this is like you walk a small step, and then you just take the line integral. So this is like a work done. So your force, maybe, or maybe your weight. So this is like line integral is something like a function times, let's say, dt, something like that. So in this case, if I put function as f for force, let's say f equals to force, and then dt is change in x. What do you understand from f time, let's say, the distance? So you have force times distance, or maybe this distance or displacement. What do you understand from this? tingkatan 4 ke tingkatan 5? Apa awak faham? Force time displacement, daya darab sasaran. Tak ingat?
Wait, kan?
Kejap je awak cakap. Atau mungkin awak boleh tulis ke?
Work done.
Yes, work. So W. So W is F times D. Okay. So in short, untuk dalam case ni, line integral is the work done on something. Okay. Kalau contohnya kalau saya lagi satu, kalau saya tak bergerak, so maksudnya no displacement, so tak no work done. Ataupun saya bergerak tapi saya end up, katakan saya daripada sini. Okay, so saya dah start pada sini, saya berakhir tempat yang sama. So saya tak buat kerja, seolah-olah saya tak buat kerja. So because work is zero. Okay, so maksudnya apa? Maksudnya kalau awak buat apa-apa tapi berada pada tempat yang sama, tak berubah, tiada perubahan, tak buat kerja langsung. Okay. Lagi satu kemungkinan, this is in terms of physical understanding. Satu lagi, line integral boleh juga digunakan untuk, for example, siapa pernah okay, tak apalah. Okay, kalau ada ni, let's say this is jambatan Pulau Pinang. Okay, jambatan lebih kurang lah. Jambatan Pulau Pinang. Dia ada kabel dia. Okay, so this is kabel. Kabel dekat jambatan Pulau Pinang. Setiap kabel ni dia ada dia punya dia kalau awak pegang kabel ni, kalau awak contohnya kalau awak pegang ada kabel dekat sini, the weight kat sini, this is like let's say TK, and then this is like TN. Okay, the weight kat sini ataupun berat kat sini, jisim dia kat sini tak sama dengan jisim yang di sini. Sebab elevation dia berbeza. Okay. So in that case, kalau saya guna line integral, contohnya saya nak, kalau saya besarkan, saya zoom in, so dia punya kabel dia macam ni. Okay. Dan dekat TN, kabel dia macam ni. Okay. So kalau saya nak cari, jumlah, if I want to find the total mass of this cable, saya boleh cari, let's say position at TK, DTK kat sini, dan DTK, DTN kat sini, a small t, D in this case meaning that I'm gonna be saya guna delta because this is discrete. This is approximate. Okay. So dalam case ni, saya boleh guna apa ni? Saya boleh guna small weight. So saya akan darabkan dengan delta Ti. So this is also line integration. Saya boleh, so dalam segini lah. Ataupun satu lagi, let's say I have some kind of, kalau saya naik gunung, okay. So let's say this is the path that I've taken. So kalau saya lalu ikut jalan ni, this line. Okay, so this is my path. Dia punya function dia adalah let's say f. Okay, then small area yang saya lalu ni pun, let's say this is dx. So not dx delta x. Okay. So dalam kes ni pun saya boleh faham line integral juga membawa maksud f times delta x, which is your area. Same thing. Okay, so dia membawa maksud yang apa ni, berlainan setiap dalam setiap problem yang kita nak check. Alright, let's go back to our ada 10 minit je lagi. Padam, saya nak padam jap. Tak apalah, tak padam. Okay, let's see. In most cases, in most of our problem, we are only interested in closed curve, integration in closed curve. Sebab apa? Sebab okay, dia berkaitan dengan fizik sikit. Sebab dalam fizik, everything should be conserved. So the work should be conserved, meaning the total work is zero. Any forces should be conserved, so the total force is zero. So mungkin awak tak nampak lagi dalam kes ni, tapi saya cuma cakap saja dulu. So selalunya we are only interested in closed curve because it's related to the physical behavior of nature. Okay. So apa yang kita nak buat? Let's say we have a closed curve in both direction, meaning that we are going to have linear integral in terms of dx and also in terms of dy. And then P and Q, P is a function f xy, Q is also a function of xy. Okay, contoh, example. Compute the closed curve of 2xy minus x squared dx plus x plus y squared dy. So this is closed curve. And then C along y equals to x squared and x equals to y squared. From point 0, 0 to 1, 1. Okay, so it's given, everything is given. So in this case, we can see that P equals to solution. So P equals to 2xy minus x squared. So P is the multiplier for dx, and then Q is the multiplier for dy, x plus y squared. And then how about the curve? Let's see. This is the first curve is y equals to x squared. So let's sketch the path. Okay. I told you always sketch the thing. If you see something like this, anyhow, just sketch the graph or surface. If you don't get the idea, just by sketching you can see the boundaries. Okay, y equals to x squared, x equals to y squared from 0, 0 and 1. So the point 0, 0 is right here. The point 1, 1 is right there. Okay, y equals to x squared. So this should be this line. So this is y equals to x squared. This 1, 1, 0, 0 at the origin. and x equals to y squared. So this is the other way. This is x equals to y squared. Okay. So it starts from 0 to 1. So it starts from here and then go back to the original position. Okay, how about the path? Okay, let's say we need to evaluate this line first. Okay, so along this line first, we take this one. So along, we don't have much time, along y equals to x squared. So meaning that we need to put y equals to x squared. Okay, so the path should be from in C, P is, let me write that before that. Okay, so along x, y equals to x squared. So P equals to 2x, y equals to x squared minus x squared. Okay, and Q is x plus y squared, which is x squared squared. Okay, how about dy? Dy is 2x dx. Dx doesn't change. Okay, so we go back to our original question. So dx start from 0 to 1. Okay, p is 2 times x cubed minus x squared dx. Okay, and then we have plus q. Q is x plus x to the power of 4. And dy is 2x dx. So let me just write something above this. So this is like p times dx. Maybe at the bottom is better. So this is p times dx. This is q times dy. Okay. Okay, so just one last simplification. So we just simplify this. Okay, so simplify this. We have from 0 to 1. So 2x cubed. Should be x, this is same thing, minus x squared plus 2x squared plus 2x to the power of 5 dx. So just multiply the coefficient and we end up with integrate from 0 to 1. The highest power is 2x to the power of 5 plus 2x to the power of 3 plus x squared dx. Okay, then you solve this. Try to evaluate that on your own. Okay, I don't have the time to finish this. You can go from, so that one is on y equals to x, then you can do another one along x equals to y squared. Okay, so in this case you need to define p. P is now 2x y, so it will be 2 y squared times y minus x squared. So minus x squared is minus y squared. And then q is what? X plus y squared. So x is y squared plus y squared. Okay, and then you find dx equals to ada masalah USB. Okay, dah lama sangat ni dia jadi masalah. Okay, tak apalah. Nanti saya ni. Sekejap my USB ada problem lah pula. Alright, tak apalah, ada okay. Apa ni saya perasan yang ada saya macam terstop somewhere. Okay, tak apa. Okay, ada